Okay, good morning, everybody. As we've seen, I guess, in the previous few lectures, a lot of the data, well, all of the data you'll be working with basically is stored in a file of some kind. I suppose you could also get it from the keyboard, so you could get user input from the keyboard, but most of the data we'll be working with comes from a file. And so it's important that you understand how to work with files. So in Unix, you're allowed to name a file with any character that you using any character that you would like, except for the /, because the / is the directory separator. And so that means there are that means you can have things like spaces or return characters or symbols in your file name. Now, we've already seen that the space is important to the shell. So here's an example. So in the directory scripts quoting, so this is under your bash, under the bash directory for the notebooks. There's a directory called quoting. And if you look in that directory, there's some files in that directory. Right? So there's file with spaces in name, file with star in name, file with question mark in name. Right? And you'll notice that the shell single quotes the file names. The single quotes aren't part of the file name. And so the shell is putting in the single quotes to indicate to you that the thing inside the single quotes is the entire file name. And so if you wanted to look at the contents of one of these files, so say a file with spaces in name, right? So remember, to look at the contents of a file, you can always use cat, right? So concatenate the contents of the file to standard output, right? And you might type in with spaces in name, like that, right? Because the name of the file is file with spaces in name. Now, if you press enter, you'll get an error. Right? And so the error that you get, cat complains. It says, I don't know what this file name file is. I don't know what this file name with is, and et cetera, et cetera, et cetera. Right? And why does that happen? It's because bash uses the space to separate arguments. Right? So the space is the word separator in bash. So as far as cat's concerned, you're asking it to concatenate the contents of 1, 2, 3, 4, 5 different files. Right? And those files don't exist in the directory, so it complains. And so at the very least, the space character needs to be treated specially when you're using it in a file, when you're working with a file name that has a space in it. Right? And so quoting is bash's mechanism for dealing with spaces. For dealing with special characters. Now, unfortunately, there's 2 different types of quoting, and there's a special character that you can also use. And so they all have slightly different meanings. So let's take a look at what they do. So if you're running the notebook, you need to run that first cell first to get into that directory that I just showed you. OK, so the first thing that you can do is that you can remove the meaning of a special character by inserting the / character in front of it. Right, so notice it's the /, right? It's not the /. Right? The / is the name of the root directory, and it's the directory separator. So the / is what's called the shell escape character. Right? It preserves the meaning of the next character that follows the /, right? In most cases, not all cases. Right? So for example, it does not preserve the special meaning of the new line character. So for example, if you wanted to look at the contents of the files that I just showed you in the previous directory, one way that you can do this is you can insert a / in front of the special characters. So I'll come back to this example in a second. Let's just jump back to the terminal and see how we can deal with file with spaces in name properly. So up arrow, right? And now I can replace the spaces with a / space like that. Right? And that one, and that one, and that one. Right? So / space means do not treat the space as a special character. Right? Preserve its literal meaning. And so now this works. Right? So now it concatenates the contents of that file to standard output. If you're doing this now, or if you're doing this later on at home, the files that I'm showing you are very slightly edited than the ones you have. I inserted this comment or this line at the top of each file so that it's easier to see what the actual file is. You're missing that line in the notebook files that you have. All right, so notice notice what's in the file. There's basically one line that says avoid using spaces in file names. So if you want your life to be really easy, right, you will always avoid using spaces in file names Unfortunately, in the real world, you can't get around the fact that you are allowed to use a space in a file name. So for example, if you're getting input from a user, right, you have no idea what the users name their files, right, and they've used special characters in their file names, you need to know how to deal with these special characters. Okay, so what about the star? Right, so there's a file called file_with_star in name. So remember what the star means, right? The star matches any sequence of characters when you use it as part of a file name. So if you just tried to naively type in, look at the contents of that file by typing in file with star. Sorry, star in name. Like that, right? You don't get the contents of one file, you get the contents of two files, right? So there's the contents of file with star in name, and now there's the contents of file with question mark in name, right? So why does this happen? Well, it happens because that star, right, expands to match anything that starts with file with underscore and ends with underscore in name. Right? So in other words, that star expands to match that file name, right, and that file name, right, because they both match that globbing pattern right there. Right? And of course, the same thing's going to happen if you use the question mark. So remember, the question mark matches any single character, so it's going to match both the literal star and the literal question mark, right? And again, you get the same result here. How can you avoid the problem? Well, use the backslash to remove the special meaning of the character. Right? So backslash star. Now we only get the contents of file with star in name, right? Backslash question mark, and now you only get the contents of file with question mark in name. Right? And so there are some examples of using the backslash to remove the special meaning of a character. Okay, so you might now ask, well, okay, so what are the special characters that you have to worry about? And so if you go onto Stack Overflow or search the internet for this, you'll find, you'll probably come across this Stack Overflow question. And in that question, someone posts the following answer. Right? Well, you can run this little script and you can see what special characters you might have to deal with. So the special characters are basically all symbols and spaces and things like that, white space, right? And so at this point in the course, you probably can't understand this script. But I can explain to you what's going on here. So the first line here, you've got something equals. So that's a variable assignment in Bash. So we're creating a variable called special. All variables in Bash are strings. So this is defining a string. There's a dollar single quote, and there's an ending single quote. So this is one way that you can create a string that has a bunch of special characters in it and not have to worry about what's inside the string. Right. OK, so notice what's inside the string. We've got that set of characters there. So there's the backtick, the exclamation mark, so on and so on and so on and so on, right? These are basically all the symbols that you can type in on a standard English keyboard. Right? So we have a string containing all of the special characters that people working on an English language keyboard are going to might encounter. The next line is one form of Bash's for loop. So this looks a lot like a Java-style counting loop or a C-style loop. So basically, this is a loop that counts from 0 up to that funny syntax there is the length of the string special. So when we talk about strings, I'll tell you how to get the length of a string. That's how you do it. Right? And of course, we know what I++ does. That just adds 1 to the value of I. OK, so right there, we're going to grab the ith character of special. Right? So in Java, you would write char at. In Python, you do square brackets I. In Bash, you have to write something else. Right? The something else is gross, but that's the way it is. Right? So we're going to grab the character. The next line is we are going to use the function called, the command, called printf. So printf, you probably haven't seen in 124, at least not if you took it with me. Printf is what's called formatted print. It lets you specify stuff to print and how to print it. We'll see this in great gory detail when we talk about C. So here we're going to print, so that thing there means print the character in a way such that if it's a special character, it prints in a way so that it does not the shell doesn't interpret its special meaning. Right? That simply prints the character that we got on the previous line. Minus v prints, instead of printing to standard output, it prints to the variable, in this case, the variable qcar. The next line is an if statement that tests whether or not qcar and car are the same character. Right? So if they're the same character, if they're not the same character, not equals. If they're not the same character, that means it's a special character. The shell you have to do something special if you want to use it as part of a file name or variable name or something, part of a file name. If the characters, when they print out, if qcar and car are the same, then as far as the shell is concerned, it's not a special character. So if you run this little script here, so there's your for loop. It ends with done. So a for loop in bash is just a command. So you can take the output of the command and send it somewhere else. So here we're going to pipe the output of the for loop to the sort command. And so this is going to sort the output in alphabetical order. Right? And so now you get the output here. So it looks like the % sign, the plus sign, and the minus sign, you can use those safely. It's part of a file name. You don't have to do anything special with them. Right? The dot, well, that makes sense because we've seen the dot in file names already, and we haven't been doing anything special. Right? You're not allowed to use the the // story as part of a file name, so you don't have to treat it specially either. But what does need to be treated specially? Well, the space does. Right? Exclamation mark, the double quote, the single quote, and so on and so on and so forth. Right? And so there's a lot of characters that you have to be, that have special meaning to the shell, and they need to be treated specially if you choose to use them as part of a file name. So you're either going to use the / in front of the character to remove its special meaning, or you're going to do something else. Right? Now, obviously, remembering this list is going to be very awkward. Right? Like no one remembers all of the special characters. Well, probably no one. So it would be nice if there was a different mechanism other than just the / to handle these special characters, and there is. Right? So you can escape the special characters. So we talked about all of that. You can also use single quotes around stuff, right? Around parts of a string or around the entire string if you like. Right? And so single quotes removes the special meaning of all characters. Right? So anything inside of a pair of matched single quotes, you get the literal value of the character. Right? The characters have no special meaning. So if we go back to our terminal, we can, instead of using a / to remove the special meaning, so I'm going to go back to file with spaces in name, I can surround the entire thing with single quotes, like that. Right? And now that works just fine. If you really wanted to, you could surround all of the special characters with single quotes. I don't really want to do this, but I'm going to do it anyway. Okay, so I know the space is special, so if I really wanted to, I could just surround the space with single quotes, and everything is fine. Like that. So that will also work. Right? So in bash, that's a string. Right? That's also a string. String concatenation, you don't have to do anything special. You just write the two strings beside one another, and they get stuck together. And so later on, we talk about string concatenation. There's nothing to talk about. You just write the two strings together, and they get stuck together automatically for you. Right? You don't have to surround just the special characters. Right? You can surround any part of the special character. Sorry, you can surround characters that also include other characters. So I can do that. No problem. Right? So there is my first string. Right? I've got single quotes around it, so the space doesn't matter. Right? Here's the start of my next string, and there's the end of the next string. Right? Single quotes strips the meaning of all the special characters in between, and so that also works just fine. All right, any questions so far? So single, yes?
If the file name contains single quotes, then you have to worry about it.
You cannot put the single quote inside the single quotes, right? So that's the problem. So now you need yet another mechanism to deal with the single quote. So what's the other? So one solution is to, well, so you can't use the / because the single quote strips the meaning of the /. So you need something else instead. Not surprisingly, it's the double quotes. Okay, but double quotes, it has yet another wrinkle. So double quoting behaves like single quoting, except except some characters still have their special meaning. Right? So the dollar sign, which you're going to see over and over and over again in the first few weeks of this course, it retains its special meaning. Turns out the dollar sign is how you get the value of a variable. Weird, I know, but that's how it works in Bash. Right? And so if you use a dollar sign inside double quotes, it still works to get the value of a variable. The backtick is no longer, the backtick used to be used in older versions of Bash. You don't see it so much anymore in newer versions of Bash. We're not going to talk about that. Oh, there's a bug in this notebook. And I haven't fixed it yet, I guess, either here or online. So you remember I said the backslash removes the special meaning of all characters. Well, it also does that in Markdown, which is what these notebooks are written in. And so I need the backslash here. Right, so it's not angle brackets code, it's actually the backslash character here. So inside double quotes, backslash retains its meaning. So you can still escape special characters using the backslash inside double quotes if you'd like. Right? The exclamation mark also retains its special meaning if history expansion is enabled in your shell, and most of you that will be the case, I believe. Okay, but there's lots of exceptions in Bash. Right? You don't have to worry about remembering all of them for the purpose of this course. Right? I generally don't test you on all of the special little cases here. Okay, so the behavior of backslash is modified inside double quotes, right? And so only the the only characters that are escaped with the backslash inside double quotes are the dollar sign, the backtick, the backslash, and the double quote, right? And the new line character if you want it inside, right? All of these special cases are needed in order to make to avoid all of these funny cases. So double quoting is probably the most common form of quoting that you'll see if you're reading other people's Bash code. Right? It allows you to, by using double quoting instead of single quoting, you can get the value of a variable inside the double quotes, which is often useful. Whoa, sorry. And double quoting is also useful to suppress file name expansion when you're working with variables. All right, so let's see how this works. Not surprisingly, in the example here, it works the exact same way as single quoting. Okay, so go back here, change the single quote to a double quote. Like that, right? So surround the entire file name with double quotes, everything's fine, right? Surround just the special characters. Well, sorry, surround. This is very tedious, sorry. Surround just the special characters with double quotes, also works just fine. Obviously, you're typically going to just surround the entire thing with double quotes, right? And again, you can surround, you can make sure that all of the special characters are surrounded with double quotes, but you can also include other stuff when you do that, right? So I can do that, and that works just fine as well. Right? That space is enclosed inside of a pair of matched double quotes. All right. Okay. There's another line here that's not going to make sense to you at this point in time. So double quoting prevents what's called word splitting in Bash. So the example I showed you here was an example of word splitting. So when you don't right, so when Bash sees a string or a sequence of strings separated by spaces, right, it considers each thing a separate string, right? So it won't treat that as a single name, right? And you get that error there. Double quoting also prevents file name expansion, right? So if you look at one of the file names with here we go. So with the question mark, right, if I double quote that entire name, right, that prevents the question mark from being interpreted as match any character, right? And so it just becomes the question mark, and so you only get the output. You only get the contents of the one file. Right? Again, just like the spacing, you don't have to surround the entire name. Right? You can just surround the question mark. Right? So it prevents what's called globbing, or file name expansion. Right? And it also prevents this thing called brace and tilde expansion. We'll talk about those in a couple of lectures. Other stuff still happens inside of double quotes. And so you can get the value of a variable inside double quotes. That's called parameter expansion. You can do arithmetic inside double quotes. That's called arithmetic expansion. And there's something called command expansion. So you can run a command inside of double quotes. So that still runs as well. That still works as well. Right? Again, there's a notebook that covers these things later on. All right, so any questions so far? So if your file name has special characters in it, you have to do something to deal with the special characters. You either use a backslash to escape the special character or characters. Right? You can use single quotes, and you can use double quotes as well. All right, so we're going to move on to the next notebook. So we've just covered quoting. And so now we actually want to start to look at simple ways of making files and how to work with files, such as moving them, renaming them, and copying them to different places. OK. So what the introduction of the notebook says is a quote from the book, The Art of Unix Programming. So this is written by one of the people who's worked a lot on the development of Unix. His name's Eric Raymond. OK, so this says Unix has a couple of unifying ideas or metaphors that shape its APIs and the development style that precedes them. The most important of these are probably the everything is a file model and the pipe metaphor built on top of it. And so Unix considers, you'll often see this phrase, everything is a file in Unix. Right? And so what people mean when they say that is that Unix provides a single, oops, sorry. It's really hard to, OK, here we go. Unix provides a single abstraction performing input and output. Right? So input, so reading stuff from a keyboard or reading stuff from a file. Output, or some other device. Right? Output, printing stuff to the terminal or printing stuff to a file or something else. Right? Everything works in the same way. And so if you want to read or write a file, right, it's the same thing happens when you read or write a directory. Right? If you read something from the disk, that works the same way. Right? Everything goes through a file. So for example, your hard disk or your flash drive, right? In Unix, there's a file that corresponds to that device. Right? If you want to write something to the device, you just write something to the file. Right? If you want to read something from the device, you just read from the file. Right? Even some networking stuff can be accessed using the same basic framework, even though networking really doesn't really fit into this everything is a file model. So when someone says computer file, all that really is, it's just a bunch of bytes. Right? It's just a sequence of data. So reading the contents of a file, you can think of that as just reading the stream of bytes from the file. Right? And when you want to write data to a file, you can simply think of that as writing a stream of bytes to the file. OK, so you need to run that cell there to make sure you're in the right directory in the notebook. OK, so file names in Unix, so as I've already told you, you can use any character you want to except for the path separator. Right? You're also not allowed to use \0. So when we talk about C, \0 is what's called the null character. It's the literal value, it's the numeric value 0. You can use the character 0. You can't use the numeric value 0 in a file name. The reason you can't do that is because the \0 or the null terminator is used to indicate the end of a string in C. So when we talk about C, you'll learn that every string has a special character at the end of it whose numeric value is 0. So you can't use that value inside of a Unix file name either. Right? File names in Bash are case sensitive, and that's true in Mac as well. It's not true in Windows, which is really annoying. So in Windows, you can have a file name ABC, and it's the exact same file as the file name, all uppercase ABC. Right? In Unix, that's not the case. Right? So the file name little abc is different then the file name uppercase ABC. So case matters. Right. We've also seen that if your file name starts with a dot, the shell normally considers it to be a hidden file. You can configure your shell to always show you the hidden files if you like. Most people don't. Most tools treat the dot as though it, most tools treat files with a dot in front as being hidden, and they don't process those. And of course, we've seen that there's a bunch of characters that are considered special to the shell, right? It's not forbidden to use these characters in a file name, right? And in particular, space is quite common in a file name nowadays. I think in the past, it was not so common because Unix programmers were aware that the space was special. But with the rise of Windows and Mac, where you have these graphical file explorers, people have started to increasingly use spaces in their file names. Right. All of these other characters too, they have special meaning to the shell. You're still allowed to use them in the file name. One of the things you really ought to avoid is if you have if you're naming your file, you should not start with the hyphen. You're allowed to, but you shouldn't start with the hyphen. Right? Why shouldn't you start with the hyphen? Right? So remember, how do you use an option in bash, right, or in the shell, right? Options always start with a hyphen. So here, if I use the hyphen, the option -d to list the contents of the directory, I don't get any information because there are no directories, right? But if I had a file name called -d, right, now I have to quote the file name, right, to take away the special meaning of the hyphen, right, in order to prevent the shell from treating it as an option, right? So that's a bit annoying. So don't avoid naming your files starting with a hyphen. Right. Okay, and so if you start to search for information on bash programming online, you'll see a ton of advice. Right? Almost all of it is devoted to explaining why certain constructs are needed to deal with special characters and file names. Right. So you'll see lots and lots and lots and lots of information about when you do and don't have to quote, for example. All right, so if at this point in time I gave you a bunch of files, you could do some stuff with the files, right? You know how to run commands on them, you can look at the contents, you can list them, and so on and so on and so forth. I haven't told you how to create a file yet. For most people, I guess in this day and age, the way you create a file is you open up some program and create the file. Right? So you pop open Visual Studio Code and you write a bash script. Or you fire up Word and you write a Word document. You can create files from the command line as well directly. Right. So for example, the touch command creates a file if it doesn't exist. Right? If it already exists, it does something else. Right? Okay. So this wants me to, did I run that? Sorry, I have to go back up and make sure I ran that. Nope. Okay, so I'm already there. That's fine. Okay, so if you look at the contents in the directory, and I run my ls, what do we see? Okay, this says it should only list dir1, file1, and a.text, which of course is a lie. There's also a word starting with a here. dir1 is here, so that's good. dir1 is there. All right, so on the next line, you see there's a command called touch. Right? So touch space file2 space file3. So touch, when you give it a file name, creates the file name if it doesn't exist. Right? If it already exists, it changes the modification time of the file. Right? So in other words, it's like you opened the file, did something to it, and saved the result, and closed it. Right? Where the did something to it doesn't actually change the contents of the file. So if I now list the contents of the directory, right? So we got that before. Oh, sorry. Oh, do I not relist the here? I'm going to relist the contents of the directory here. Okay, so notice now, the second time that I run this, here we go. So now the files file2 and file3 have appeared, right? Because touch has created those files for us. There's nothing in those files, so it creates empty files for you. So if the file already exists, touch updates the access and modification times of the file. So I'm going to use ls with the -l option. Again, the -l option is the long listing option, so it gives you extra information about the files. Okay, so when I list the file the first time, right, it says that the modification time was January 6 at 2 p.m., well, 2:52 p.m. Right. When I touch the file, right, and list the contents again, notice that the modification time is updated to, so this is the current time in this particular version of Bash. Obviously, it's not accurate, because this has been running, I've left this running for many, many days now, so it's lost time. But that is now the updated modification time. If I do this in my shell directly, in the terminal directly, sorry. Oh, it's already here. So yeah, so this shell's been running for some time now. So my shell thinks it's actually yesterday at 11 p.m., which is fine. That is in fact the current time as far as the shell is concerned. Okay, so you can make a file by using touch. Okay, so what if you want to make a directory? So touch won't make a directory, right? But if you want to make a directory, you have to use the command makedir, so mkdir, right? And so all makedir does is it makes one or more named directories. So here, I'm going to print before makedir, and then I'm going to list the contents of the directory. I haven't shown you double ampersand yet. And so double ampersand is one of the command separators. Right? And so what double ampersand does is it runs that command. Right? If that command succeeds without error, it runs the next command. Right? Echo always works as long as there's a terminal. Right? And so this prints before makedir, echo succeeds, so then lists the contents of the directory. Right? On the next line, we're going to make two directories, dir2 and dir3. And then we're going to print after makedir and again list the contents of the directory. Right? So before makedir we had all of that, right? And after makedir you can see that dir2 and dir3 have appeared. Right? All right, so it's often the case when you're making a directory you don't want to make just one, but you want to make a directory, and inside that directory you would like to make another directory, and inside that directory you would like to make another directory, and so on and so on and so forth. Right? So you want to make a hierarchy of directories. So for example, I might want to try to do something like that, right? So I'd like to make the directory xxx, right? Inside xxx, I would like there to be yyyy, and inside yyyy, I'd like there to be zzz. If you try to do that with makedir on its own, it's going to fail, right? So it's going to fail because it's going to try to make directory zzz first, right? And it can't do that because yyyy doesn't exist. So when you run that, it complains. It says, I can't do that. Right? So how do you fix this? So you could manually create them yourself. Right? So I can make xxx first, right? And then I can make yyyy inside of xxx. Right? And then I can make zzz inside of yyyy. So that would work fine. Except you have to type it in 3 times. It's really annoying. If you're making a long hierarchy of directories, it's going to be very annoying. So there's an option -p. Right? -p is short for parent. So make the missing parent directories if they are required. Right? So makedir -p xxx yyyy zzz makes xxx and yyyy and then zzz. The tree command's probably not installed on your operating systems. So if you want to use tree, you have to on Ubuntu, you'll have to use apt to install it. I don't know if it's installed on Mac or not, because I don't use Mac enough to know whether it's there. But the tree command, oh, I guess I don't have it either. So I don't know if this works either. If I do this now, sudo apt install, if this fixes the issue in the notebook or not. Oh. So I wouldn't be surprised if this doesn't work. Oh, it works. Hey, look at that. I am surprised. Okay, so tree draws a graphical depiction of the files in your directory, right? So it's a very crude. It's a very crude version of like Windows File Explorer or Mac Finder, right? And so here you can see that it starts in the current directory, right? And in the current directory, there's a file called a.txt, right? You can see there's directories dir2 and dir3. and there's XXX, and inside XXX is YYY, and inside YYY, there's ZZZ. All right, so another way that you can create a file is through a mechanism called redirection. And so a lot of the commands that we've been using, they produce some output. Right? So for example, cowsay prints a cow and then that says some string. Right? If you want to save the contents of the output, you can. Right? Use what's called a redirection. Right? And so to redirect standard output to a file, it's the greater than operator, right? Or the greater than sign. So command, right? Greater than name of a file, right? So that will run this command, right? Whatever output was that would have been sent to standard output now gets sent to a file instead, right? So it redirects the output, standard output, to a file. And so if we do, is that the last? No, this is one. OK. So if you do that and run that, right, no output. Right? Normally, cowsay on its own, so if I get rid of this redirection, right, prints the cow. Right? Whoops, sorry. So with the redirection, you don't get the output. What did I call it? Moo.text. Right? With the redirection, no output, right? And that's because the output that would have normally appeared has now gone to a file. So if you now go and look at the contents of the file, so use cat, look at the contents of the file, now you'll see the output that cowsay generated. Right? And so so when you're working just on the command line, right, without the help of an external program of some kind, right, one common way of creating content for files is to redirect the result of a command to a file. Right? Now, often you don't want to overwrite the file. So this overwrites the contents of that file. Right? If moo.text does not exist, it creates the file and writes the contents. If it does exist, it removes the contents of the file and then rewrites the new content on top of it. So moo2, right? Redirect that to the file moo.text. And now if you look at moo.text, right, it's no longer the original, right? It's now the new version of moo.text, right? And so you have to remember that the single greater than sign will always overwrite an existing file, which you may not want to happen, right? So you might end up overwriting an important file. In Unix, there's no way to recover the original file, right? So write operations to a file are permanent in Unix. Right? If you remove a file, there's no way to get it back. There's no reliable way to get it back. OK, so if you don't want to overwrite the file, but instead you'd like to add to the end of the file, that's what the double greater than operator is for. Right? So double greater than appends to an existing file, or it creates a new file if the file doesn't exist. OK, so instead of using the single redirection operator, I'm going to use the double greater than operator. That will append to the end of the file. Right? So again, run the command, append to the file, no output on standard output. Right? If I now look at the file, you'll see that there's two cows. Whoa, sorry. Right? There's the original, or not the second version of moo2, right? And then the command that I just ran again. Right? So single greater than, overwrite, redirect and overwrite. Right? Double greater than operator, redirect and append. We're going to talk more about redirection later because you can also redirect standard input. So you can redirect where your input is coming from. And you can redirect where error messages are sent to as well. OK, what about moving files? So moving files, so renaming a file is the same thing as moving a file as far as Unix is concerned. So MV, short for move, renames or moves files. Right? So to rename a file, you just give it a new file name. Right? So MV, fname is the name of the file that you would like to rename. New name is the new name of the file. Right? So I'm going to make a file called a file. and then I'm going to rename a file to b file. Right? And if I run that cell, did I kill this? This appears to have, oh, sorry. There we go. Okay, so notice when I list the contents of my directory, there is no a file, right? But there is a b file, right? And that's because I renamed a file to b file. Right? So move, file name, new file name, renames the file, right? It doesn't, so it renames the file, sorry. Both the source file and the destination file can be in different directories. Right? So if a file was in some other directory, all you have to do is specify how to get to the file. Right? So either use its absolute path name or use a relative path name to the file. Right? The destination can also be in a different directory. Right? Okay, so here I would like to take my b file, right? And I would like to move it into dir1 and also call it c file instead, right? So I can rename b file so that it's called c file, right? And it's also in the directory dir1, right? So I'm using a relative path here to get to dir1, right? You can use an absolute path to get to any directory that you want to. You can use a relative path to get to any directory that you want to, right? And so if I run that cell there, right? Notice that inside dir1, there is a file called c file. Inside the original directory, there is no b file anymore. And that's because we moved it or renamed it so that it's now in the directory dir1. Okay, suppose you don't want to rename the file when you move it, right? You just want to move it to a different directory. That's fine, right? Instead of using a file name, you use a directory name. Right? So you can move a file to another directory, and it maintains the name of the file. Right? It simply moves it to a different directory. So I'm going to make a file called z file, right? And I'm going to, on the next line, move z file so that it's now in dir1. Right? So in the original directory, after I run those commands, there is no z file. Right? But in dir1, there is a z file. Right? And so that was the file that was originally in the current directory. We moved it into directory number 1. Right? So notice there's only a subtle difference here, right? Here, it's file name followed by a directory name. So that moves the file to the new directory, doesn't rename it. Right? In the other version, right, it's file name followed by new name. So this one renames it, also possibly moving it to another directory. Okay, so again, if you rename a file so that the new name of the file is the name of is equal to the name of an existing file, the existing file gets overwritten by the file the file that you just renamed. Right? So renaming or moving a file to an existing file name will overwrite the existing file. In Unix, there is no way to recover the overwritten file. Right? For people new to the command line, so for example, when I started, when I was doing undergraduate at Queens, when I was doing my undergraduate computer science degree at Queens, we would all have accounts. The computer science department had a bunch of workstations that you would go in and work on. Everything would be in Unix. And so all of the systems were set up for new users so that stuff would not be overwritten, because students would obviously overwrite their files, and then they would go to tech and ask them if they could recover their files. And of course, tech can't do it. File deletion or writing to a file is permanent in Unix. And so all of our commands would be aliased so that they use the -i option. Right? So -i is the interactive option. It will warn you if there's a file, if you're about to overwrite something. Okay, so what the heck is here? There's a bunch of files here. Okay, so I'm going to try to move file 1 onto file 2. Oh, you know what? I'm going to edit file 1 and file 2, so hang on. This is file 1. And I'm going to edit file 2. Oops, I'm going to try to edit file 2. This is file 2. Okay. Okay, so if I move or rename file 1 so that it becomes file 2, right, and I look at the contents of file 2, right, I get the contents of file 1, right? File 2 is now gone, right? Or the original contents of file 2 is now gone, and there's no way I can get it back, right? So if you use the -I option, so I'm going to move file 2 to file 3 now. Most options, it doesn't matter where you put them. So I can put it at the end of the list as well. -I will prompt if the file exists, right? So this says, are you sure you want to overwrite file 3, right? Y or N, right? You get Y will overwrite the file, right? Right. Notice file 3 now says this is file 1, right? Touch file 4. File 3 to file 4, right? And if you press no, right, file 4 is unchanged, right? And file 3, of course, is also unchanged, right, and still exists. All right, that's a good place to stop. We'll talk about removing files in the next lecture. Any questions before we go? All right, that's it.